Joining us. Thank you, everybody, for joining us for tonight's meeting with Dr. Loren Davis. The title of his talk tonight is Deep Time Perspectives on Nez Perce Culture from the Cooper's Ferry site in Idaho. I'm sorry I can't pronounce the other way, but maybe you can say that when you're on. Dr. Loren Davis is a professor of anthropology at Oregon State University and executive director of the Keystone Archaeological Research Fund. He received his PhD from the University of Alberta in 2001 and joined the faculty at Oregon State University in 2004. His research focuses on the Pleistocene archaeology and geoarchaeology of Western North America related to the early peopling of the Americas. He is currently pursuing archaeological projects above and below sea level in Idaho, Oregon, and Baja California. He directed archaeological research at Cooper's Ferry site in Western Idaho in 1997 and from 2009 to 2018. This work produced evidence of early human presence in North America beginning at least 16,000 years ago. I want to welcome Dr. Davis. Thank you for coming, and please give him a lot of attention and give him some good questions at the end. Dr. Davis, it's all yours.
Well, thank you very much, Joe, and thank you very much to the Society for inviting me. It's always a pleasure to talk to the group. I've been a big fan of this organization for a long time, and I'm happy to be able to share some of the information about the things that I've been working on in Western Idaho that have larger implications for the archaeology of the Americas, really. So I'm going to share my screen now, and hopefully we can see the presentation. Okay, so tonight's presentation is going to be about work that I have conducted over a long period of time working in Western Idaho. And as the title says, it's really about the deep time perspectives on the cultural record of the Nez Perce Indian tribe. Where we're working at the Cooper's Ferry site, or as it's known in Nez Perce oral history, Nipéhe. This site has been occupied for a very long time, and it's been in oral history and story among the Nez Perce for, before European contact. So we're going to talk tonight about some of the patterns that we're seeing there that begin with some of the earliest record, but also go in toward the end of the Pleistocene, and how I think what's kind of amazing is a lot of the things that we associate with the Nez Perce tribe from an ethnographic historic point of view, and also other tribes of the interior Northwest. We can see the roots of a lot of these cultural patterns at the site. And I'll show you some of the evidence for this, and I'll show you the basis in which we might make these interpretations. And then toward the end, I'll tie all this together, because sometimes we tend to think about early sites like this as sort of a standalone one-off, kind of novelty perhaps, and how is this relevant to where I work or other things that I know. But there's a pattern emerging, I think, and I'm working on a paper with Dr. David Madsen and some others, where we're going to be trying to pull together a whole bunch of lines of evidence that I'll talk a little bit about toward the end, that talk about the pattern of essentially what the archaeology of at least North America might look like in the time before Clovis. So with that, let's go ahead and get started. I should also mention that I have really great partners in working here at the Cooper's Ferry site and the Baja site, and that's the Nez Perce tribe, of course, as I've mentioned, but also the Bureau of Land Management, Cottonwood Idaho office, and my colleague David Sisson has been an extremely valuable partner working through the years. In fact, there's no way that one person like me just simply presenting about it can ever do all this work. It has to be done as a team. And I'm very fortunate to get to work with some really great people. And I'm also very fortunate to be able to work at the archaeological site here that is about the heritage of the Nez Perce people. So I'm very appreciative of that too. Well, let's get into it. So roughly 16,000 years ago or so, the interior part of the Pacific Northwest probably had this kind of appearance. That is, and when we talk about years ago in this presentation, we're going to be talking about calibrated. You can think of them as calendar years ago. And then sometimes I'll talk about radiocarbon years, but I'll make it clear. I'm trying to move toward entirely just speaking in calendar years because it makes a lot more sense for most people. But 16,000 years ago, the Northwest was a very different place. And the Cordilleran ice sheet has extended way down south into much of what's now Washington and northern Idaho. And I think, as most people know, making ice the size of Canada, which is what the continental ice sheets were, this water budget to make this ice comes out of the world's oceans, and it draws down the world's oceans in the Pleistocene. And so in this image, we can see that there is extensions of Oregon's and Washington's coast. The same would be true for all coastlines around the world, including California. But it's to a greater and lesser degree, depending on the shape of the continental shelf. So Oregon has and Washington have relatively flat, low gradient continental shelves. And so in Oregon, for example, we have something like 35 miles of extra coastline to the west during the height of the last glacial period. So we expect that people would have lived out on this landscape, and much of the earliest record of the coast probably exists out here under the waves. But we're going to be talking about the area in the interior in here. In fact, near the area where today Oregon, Idaho, and Washington come together. We're talking about the Salmon River Canyon, and we'll talk about the Cooper's Ferry site. In this diagram, you can also see a bunch of blue areas, and these are areas where we have the extents of the Missoula floods came through here. So the Purcell lobe of the Cordilleran ice sheet came down and blocked the Clark Fork River and kept it from draining out to the Columbia. So it built up a huge lake network that catastrophically emptied over and over and over again. And it surged across the Northwest into the Willamette Valley, backing up the Willamette River, and then also out to the ocean. So there are geoarchaeological implications of this, because at 16,000 years ago, places like Cooper's Ferry and other areas that are up the Columbia River Basin higher in elevation, they are not affected by the mega floods. But if you're in modern day Spokane or in the lower Snake River Canyon, for example, you would have been affected by the floods. And even if we consider that perhaps no one was, physically affected by the floods, which may or may not be true, the physical process of the mega floods would have caused the archaeological record to not be preserved well in these areas. So when sometimes people will ask me, well, if people really were at Cooper's Ferry 16,000 years ago, how come we don't see it in other parts of the Columbia River Basin? Well, it could be because of this. There could be sites, I would imagine, in the uplands that are away from the river valleys. But the advantage of river valleys from a geoarchaeology point of view is that they receive a lot of sediment over time, as we'll talk about in this presentation. So sites like Cooper's Ferry get preserved very well because the river is flooding and adding more sediment over and over and over again. And the uplands, sometimes they don't receive a lot of sediment. So the archaeological record is not well preserved. So I think anyone who's ever been out to the desert in Eastern California, you can see this in action. Lots of archaeology on the surface, but it's almost the entire record sometimes is on the same surface. It's hard to tell things apart. Okay, so here's a shot looking into the Salmon River Canyon from the other side of the river. The site is located at the Star here. And the Nez Perce people, the Nipéhe, refer to this place as an ancient village site. And in the story, it's referred to as Nipéhe. And this place, as you can see, it's a mix of very arid areas and some temperate areas. So south-facing slopes are very dry and hot, and then north-facing slopes have some vegetation that's lower. The Cooper's Ferry site's positioned at the junction of a tributary canyon, and these large tributary canyons are distributed up and down the main river about once every 20 miles or so. And the reason for them being present is largely controlled by large-scale geologic processes related to faulting. So the presence of large faults actually will open the canyon up. So these are rather unusual. And the next side canyon that's large like this upriver is the location of a historic village, the Whitebird Band of Nez Perce people. So people would be attracted to these places for a lot of reasons. One is they represent sort of an off-ramp out of the canyon, but more importantly, I think they offered an avenue toward different ecology. So you could get into these riparian zones that offer different kinds of foods and other resources. And then the mouth of the river down here, or the junction, sorry, between the side canyon and the main river, is a place where you get large accumulations of driftwood. And so rather than having to haul wood down to the site, the wood just comes to you. And that's a big advantage too. So in 1997, I worked at the Cooper's Ferry site for the first time. I had learned about it as a student, and then later on, I began working for the Bureau of Land Management in Western Idaho. And this site is part of the land holdings and sites that the district office I worked in was managing. And so I just became very curious about this site. And what was important about it is in this 1960s, an archaeologist named B. Robert Butler had worked here and found that it contained a record of stemmed projectile points. And we'll get into talking about what that's about a little bit later, but stemmed projectile points, at least in terms of the archaeology of the interior Northwest, are and have been considered some of the oldest evidence technologically of people in the region. So it was in my backyard, so to speak, when I was working here. So I was just interested to learn more. In 1997, I had an opportunity to excavate here as part of my dissertation work. And you're seeing here the stratigraphy of what that looked like. So we dug a 2 meter by 2 meter hole at the Cooper's Ferry site in 1997 in order to clarify the stratigraphy and more importantly, to try to get datable materials out of the site, because B. Robert Butler wasn't able to get anything that they could get a radiocarbon date on. In the 1960s, radiocarbon dating was available, but it was focused mostly on large samples of charcoal or large samples of bone, let's say. So large carbon samples, whereas it was only really until the closer to the end of the 20th century that we got into being able to measure very small samples. So in 1997, we were able to get radiocarbon ages out of this. And what also I want to point out is the very lower part of this, you notice how it's some different color bands here. So at the bottom, there's a bit of a light colored tan, and this light colored tan is windblown glacial dust. And this darker tan above it, or brown, is also windblown glacial dust. Then we have a switch to the river flooding, bringing sand to the site, and then it's a shift entirely in the environment as the floodplain expands and becomes more biotically rich at this dark brown layer. So we'll get into talking about the stratigraphy just a little bit more, but what we found in 1997, as we excavated down into the windblown glacial dust, in this part on the left, you can see a series of photographs that were taken at 10 centimeter vertical increments. So as we would dig a level, we get to the end of it, we would take a photograph. So as we were getting to the top of the loess, it was mostly this very fine, silt dominated sediment, but there was also some rocks poking out of it. And I thought, well, that's kind of strange, because if this is windblown sediment, those rocks don't really make a lot of sense. So we kept on going, dug another 10 centimeters, found more rocks, dug a little bit more, found more rocks. And then below that, the next layer down, level down, we found a circle of dark sediment that was extending into the gray sand at the bottom of the whole sequence. Then as we dug deeper, we got into the gravels that underlie everything, but the circle kept going. There were some gravels in it, but it was really mostly fine sediment, and so on and so on. And finally, we got to the very bottom, and we were able to reveal that we had essentially excavated the interior of what I thought was a pit. And inside this circular extent is where we found these 4 stemmed points and these other tools. So we have some blade pieces, we have some flake tools, we found a hammerstone, a core, and a couple scraping tools. And so we essentially found the contents of someone's toolkit that was put in the ground, and radiocarbon ages from inside the pit and also from the surface where the pit begins, returned ages about 13,200 years ago. So that was tremendous. We were able to actually do something that wasn't able to be done before, and it demonstrated that there really is an interesting early record here. Now, remember that when we date this, we're dating when this pit actually begins. So it begins up higher up in here, and there's still a lot of, there's, you know, 1, 2, 3, you know, levels still of sediment to go below it. So I expected that there could even be earlier material here, but we just couldn't demonstrate it with our 2 meter by 2 meter pit. So in 2009, I had begun, I had been working at Oregon State University for a couple of years, and I was keen to build on the work that we had done in 1997. And now that I had a kind of a more stable situation and I could attract funding to do a long-term project, I had been talking with David Sisson at the Bureau of Land Management, and then he began a conversation with the cultural program and tribal council at Nez Perce tribe to basically begin to, you know, pitch the idea that there's a lot we could learn about the early record that we don't really understand well in this part of the Northwest. And in learning more about it, we could educate other people about what the record looks like, learn how to identify it, even how to avoid it, how to mitigate it, so on. So there's a lot of that could be learned. And we ended up getting, as David ended up getting a letter of support from the tribe that said that they, you know, wanted us to pursue this project. They thought they could learn a lot from it. And so starting in 2009, we began to do a project here. And this is a shot from Google Earth. If you know where to look on Google Earth, you can find our excavation. If you dial it back to 2013, this photograph is present. And we excavated 2 parts. One's called Area A, and Area A is near where we had dug in 97, and then also Area B, where we'll talk about these 2 areas as we go. Right next to the river, we got a lot of visitors that would float on rafts to come in. And over the years, the 10-year period we ran this archaeology field school here, we had over 5,000 visitors that would walk up and get tours, you know, dripping wet in their swimsuits and life jackets and so on. It was an unusual sight, but it was great to be able to share the work that we were doing. So here's a view inside Area A underneath the cover in 2018. So this was the last year we worked here. And by this point, we're pretty far down toward the bottom of our area of interest. And you can see what we're doing is we're excavating in 1 meter squares, and then we take them apart, you know, about 10 centimeters at a time. But the top is larger, and we just didn't want a lot of tall vertical walls next to people working. So we had to make it wider at the top and make it more narrow as we went. The students are working in teams to record as many things as they can about the size of a dime or bigger in the ground. So we have thousands and thousands of items mapped in the ground. In fact, the number is actually close to 65,000 items, I believe, we mapped in the ground. We also did a lot of recordation. Overhead here, there's a horizontal pole that there's a camera attached to it. It's a GoPro camera, and it's taking a photograph every 10 seconds. And so we compiled a whole bunch of photographs that we will string together and make stop motion movies, and we can actually observe the excavation over long periods of time. So what we see here gets closed up every year. That is, we have to fill it back in, and we don't fill it back in just with sediment. We would do it a combination of sandbags, but we also use these big plastic, they're called eco rain crates, and they basically create these sort of straw bale sized plastic crates that are lightweight, and we have to bury the whole thing every year. So it was a tremendous amount of work to get it started and do the project and close it up every year. I felt like I wore lots of hats. I was the sheriff and the garbage man and the circus ringleader and all kinds of things all the time. So it was wonderful, but it was a lot of work. So as we excavated in the site, not only did we find a lot of individual items, but we also found a lot of features. And features, again, being sort of 3-dimensional things or arrangements or patterns that are in the ground that relate to more complex behaviors than just individual items. So in this case, what we're looking at is a pit that was dug in the ground, and you can kind of see the traced in lines of the boundaries of it, and there's some individual layers inside. So someone dug a hole downward from the brown layer down into this tan or gray sand, and then they put the sediment back in. And as they did so, they kind of mixed up the sediment, and they left behind artifacts too. But we found a lot of features, and the very top of the site, I should mention, begins at close to 9,000 calendar years ago, because road construction removed about 5 meters of sediment off the top. And so as a result, we start working in the early Holocene. So a pretty early start as we get going in this. We also found things like hearth features. So on the left-hand side, this is what it looked like when we would first uncover it. And it was an ashy mix of wood ash and pieces of charcoal and fire-cracked rock and burned bone and things like this. And then as we removed just the ashy sediment away, we revealed the underlying surface, and we would see this sort of oxidized, thermally altered sediment. So again, with high heat and iron-rich sediment, which is what gives it the brown color, and water, you can drive an oxidation reaction and get this rusted. So if you've ever been to the beach and you see a bonfire on the beach, if you scrape the charcoal away at the end, you'll see this very thing. So we were very excited, of course, to see features, because features, again, are something that shows a lot of permanence, and you can begin to piece together more of the activities of what people are doing at the site. And this one here is about 10,000 years old. So this is what the stratigraphy of Area A looked like at the very end. So we got down to the basal gravels, and there's a whole bunch of layers similar to what I showed you earlier and that we saw in 1997. And we're going to focus on this lower part. And this lower part is the wind-blown glacial dust. But over the years, we realized that there was actually an ancient soil or a paleosol that had developed in here. And here you can kind of see what's called the rubified weak A horizon. So it's the beginnings of sort of stable surface through here. And then there's a subsoil horizon known as a calcic horizon. So it's a dry time when this is being created, and there's a lot of evaporation of sediment. So it's sort of equivalent to caliche. It's just not as robust as you see in the deserts of California, for example. So we're going to talk about this part of the record down here in the bottom. So as we excavated through this, the pit that I found in 1997 is called Pit Feature A2. So here it is in the stratigraphic sequence. So we're going to talk about this brown, this tan deposit that we call lithostratigraphic unit 3, or we can just think of it as layer 3. So layer 3 is essentially the wind-blown glacial dust, as I've mentioned, and this surface is, the pit is dug downward from there. We have a radiocarbon date. A red dot is a position of a date. As I mentioned before, about 13,200 years ago. Over the years, we excavated and found a lot of different materials to date. Some of it's charcoal, and that's, charcoal is the black dots here, and sometimes bone also. We're able to get dates on bone. And we found a number of other features. So we found a couple pit features that we're not sure exactly where they originate from because we couldn't find the tops of them very clearly. And so as a result, we think that they're intrusive from younger deposits down into layer 3, but that seemed kind of clear because the radiocarbon dates were a mix of old and young together. As we got deeper, we found a couple other pit features. One included a piece of bone in it that returned a date of about 13,410 to 13,745. And we also found a couple other features. This was a concentration of charcoal, ashy sediment, burned ground, burned bone. Things like this were present in, an oval shape that was very consistent with what I think is a hearth. That's how we interpret it, feature 129. It produced a whole bunch of ages that range between, 14,000 to 15,000 or so. So how is it you can get a, different range of ages in something like this? Well, you can get different ages from old trees, trees that live a long time, depending on what part of it. If you're dating the center of the tree or the outside of the tree, you can get some different ages. And then going deeper, we also found other pieces of charcoal in association with flakes from the production of stone tools, debitage, that is. We found also some pieces of bone and charcoal down here, some of which we got dated, and they pushed the age back to about almost 16,000 years. So we also found the base of 2 stemmed projectile points, and that's what these are. So here's a base of one, and it's associated with a position that's about 13,400 years ago. And this one here is associated with a stratigraphic position about 13,600. So these 2 broken pieces were found, and we're not entirely sure what they looked like, but I tried it to give an interpretation of this. So, as it says on the right, excavation of layer 3 revealed a repeated sequence of human occupation as shown in the discovery of different pit features, a hearth, stone tools, flakes, fragments of animal bone, and wood charcoal. So people were living at the site and they would leave things behind. Then the windblown glacial dust would come in and bury everything a little bit, and then they can return and return. So the burial and discard pattern just repeated over and over and over again. Now, sometimes critics will say, well, how do you know, all these things didn't just get moved by rodents? And I'll show a photo pretty soon where there are burrowing rodents at the site, but we mapped each and every single burrow separately from all the non-disturbed sediment. So we can make an audacious claim that we actually know where every single burrow is in our site. And it was a lot of work to do that. So we don't date things inside the burrows typically, and we don't count the discovery of items inside the burrows because they could be moved from who knows where. So, but burrowing rodents aren't moving fire hearths, burrowing rodents aren't moving pit features, and so on. So we have pretty good confidence about this. So radiocarbon dating shows that people were living at the site at this between the time of about 16,000 calendar years ago to 13,000 calendar years ago. And I talked about this. So there are stemmed points are the pattern that we see here. I would have really liked to see fluted points, but we didn't find anything like that at the site. And I'll talk a little bit about why I think that might be happening. We also found evidence of an extinct horse. So in this one shallow pit feature that was kind of shallow in the edges and a deep little center, there was a lot of large chunks of bone that were difficult for us to visually identify the species, but we found a piece of a molar of a horse. And it is in the position of about 14,500 in this stratigraphy. So we interpret this to mean that people are hunting extinct horse in the surrounding landscape. And if you've ever been to Southern Idaho, there's a place called the Hagerman Fossil Beds that has a world-class horse paleontology geology museum there. So some of the best horse fossils in the world come from this part of the world. So anyway, these are part of the Pleistocene megafauna that went extinct at the end of the last ice age. So here's the piece that we found on the left. It's a large fragment of the molar, and this is likely what people think that these kinds of horses may have looked like. Okay, so moving on, at the same time that we were excavating in Area A, we were also excavating in Area B, and we'll talk about this next. So Area B, we worked there for a little bit shorter time, but we had to open up a larger hole because it was a little deeper than in Area A. And also, it's a little deeper because David Sisson had made a decision, I think that was a good one, that to keep people from digging in the site and vandalizing and eroding it, he had several dump truck loads of material brought in. And so there's a really rocky, gravelly deposit at the top that's really brutal to dig through by hand. And we affectionately refer to this as the Sisson Formation. And the Sisson Formation very much helps to protect the site, but we had to use machinery to get through it. And so these are the crates I was talking about, these black crates, and we would fill up this entire thing with these black crates, put plastic on top and plywood, and then we would bury it under about a foot of sediment. And when they're packed really tight like that and buried properly, you can park a fully loaded log truck on top of it and they won't collapse. So that made our work much, much easier. So in excavating in Area B, we found a lot of features. In fact, more features, I think, in a concentrated area in Area B than we see in Area A, but we don't see as much distribution of artifacts compared to outside the features compared to Area A. So in the photo on the left, we can see students are working very carefully to excavate some different features. In fact, from left to right, so Glenn is working on this one pit. You can see the top of it, the shape. We've got students working on other ones that have piles of rocks at the top. Sarah's working over here on another one, and there's another pit feature that's being exposed here. So a lot of different pits coming together. So at the left, on the right-hand side, we can see an example of the stratigraphy of this wall. When it finally gets dug all the way back, we get to see kind of a final state of it. And there was a pit feature here that's being worked on in the corner. It's called feature 110, and it had these rocks piled on the top. It returned radiocarbon ages that were in the 11,000 year range. And this one here that's being worked on in the middle is also returning ages between like 10,600 to 11,000 or so. So very large pits, because this is a meter across right down here, very large pits being dug, and they're just loaded with cultural material also. So here's an example from one of my students. Kirsten Paulson did her master's thesis on pit feature 110. And here she's looking at, made a map of showing the distribution of things like debitage and blue dots, these flakes. There's also large pieces of rock that are in here that didn't look like they're modified, but they might have been part of marking the top of the pit. We also see pieces of unknown animal bone, pieces of stone tools, projectile points, and also some unusual animal parts like wolverine and other kinds of things. So here we can see as the excavation of feature 110 is going, they found a stemmed point here made of like an andesitic or basaltic material. And then as they kept excavating, they found other ones. They found these other stemmed points, one of which was broken. They found the blade, and then later they found the haft element. They went back together. So someone is putting these stemmed points in the ground between about, in the 11,000 year range. Also in the same pit feature was a piece of a mandible of a wolverine. And this dates to, again, in this 11,000 year period. And interestingly, students, excavators also found a mandible of a canid. And when we say canid, as we can see right here, what we mean is this. It's a dog, a wolf, a coyote, probably not a jackal, or a fox. We tried to have DNA done on this to extract, genetic information out of the canine tooth, but there are some micro cracks and it didn't preserve very well. So we haven't done more on this right now, but in Kirsten's thesis, she looks at geometric measurements of teeth and compares them against other canids from North America that are in the archaeological record that genetically have been shown to be wolves or coyotes or domesticated dogs. And the one from feature 110 actually classifies out metrically as smaller than a wolf, larger than a coyote. So it's either a dog or it's a hybrid of a dog and a coyote, we think. So at 11,300 years ago or so, this represents the second oldest evidence of canid, probably a dog, in the Americas. The earliest one comes from the northern part of Vancouver Island. Canine tooth that yielded dog DNA was actually found up there, and it dates to about 13,000 years old. So on the other side of Area B, pit feature 01, as it's known, or 59, it gets another number later, was excavated, and another one of my students, Amanda Carroll, did her master's thesis on this, and she looked at the distribution of items and tried to make sense of what was going on. In this wall here, you can see the shape of the pit as it extended down, and here's the mapped, sort of as if you had X-ray vision looking through the sediment. You can see all the items in here. And the stemmed point was found in this deposit as well. At the very bottom of the pit, when we got down, there was basal gravel deposit, as we see other parts of the site. And there were some large pieces of bone, animal bone, in the bottom. And so we had these pieces come out fragmentary, but we did 3D scanning of them and then assembled them digitally. And so this is what we were able to put together. And then we had this printed, and I walked it across campus to the Fishery and Wildlife Program's comparative collection and found a match for this. And the match for this is this animal. Again, another wolverine showing up in a different pit feature in Area B. And this one dates a little bit younger, to 10,700 to 11,100 or so. So at first I thought, well, that's really just amazing. I mean, why are there wolverines showing up at Cooper's Ferry? I didn't realize that that was ever going to be a thing. Well, it turns out that wolverines are not that unusual in Idaho. In fact, in North America, most of the wolverines in North America are living Alaska and also in Canada, but we do get wolverines in the Cascade Range, extending also down in the Sierra Nevadas sometimes in California, but also there's a robust population in Idaho. And in this map, we see the point locations of known distributions, observations of wolverines, but the predicted distribution is this gray area. And here we've zoomed in, and Cooper's Ferry is located about right here. So this inner circle is 10 kilometers or 6 miles. And this outer one is 20 kilometers or 12 miles. So within a easy day's walk out and back, you will encounter wolverine habitat. And wolverine habitat around Cooper's Ferry is going to be winter range habitat, because in the winter, wolverines come down in elevation and will live where the snow accumulates in low elevation. In the summertime, they go to high elevation areas where it's colder. This is what I just said, essentially, but they're going to be in these mid-elevation areas during the winter. And that's pretty close to where Cooper's Ferry is. So I guess we shouldn't be too surprised. There's wolverine habitat in the immediate area around the Cooper's Ferry site. So in excavating toward the very bottom of Area B, we kept finding some pit features. And in fact, this is an image showing a pit feature on the right. This is feature 78. So you can see the contrasting color. It's pretty obvious where the inside and the outside of the pit is, I think. And then also, as we excavated, I had the students try to map everything they could find in place. So on the left-hand side, you can see a plan view looking down from the air, distribution of all the items inside the pit features. So feature 78 has loads of debitage, but also has a lot of pieces of bone and has some fire-cracked rock, has projectile points. And then the other pit features, 151 and 108, have fewer items, but 108 has a lot of projectile points. So that's pretty amazing. Also, projectile point was found outside the pit features in this lower sort of loess and sand deposits down below. So this is what we found inside the pit features. And these date to between 15,240 to 16,675. And the age range is something that we use because there's statistical uncertainty in every radiocarbon date. You may hear presentations made by archaeologists where they will give you a single age, and I have talked about single ages here too, but in truth, we're always need to be thinking about them as statistical approximations, because it's hard to measure time that precisely going backwards in time. So this is why I often just use a shorthand of around 16,000 for this. But feature 108 had these stemmed points in them. Feature 78 had these 4, and these 2 stemmed points came from outside the pit features. This is the earliest, that is stratigraphically deepest one. I don't know the age of it because all the radiocarbon dates come from the pits themselves that are a little bit higher. So this one is older than 16,000 by some amount of time. I'm not entirely sure. But what's amazing is I think this little one here, in fact, this little one fits on your thumbnail. So it's really small, and the edge has been ground down to be dulled, likely to be hafted onto a stick, a shaft of wood or bone or something like that, antler maybe. And also it has evidence it's been pressure flaked at least once to resharpen the edge. Because as the blade is resharpened, we see that the width of it gets less, gets more narrow. And if they are tied up in sinew and attached to a stick, sometimes we think the sinew is tied onto the bottom end of the blade here, and this little nub here gets preserved. They're pressure flaking this part, but not this, because it's being preserved in the haft. We can see that in a couple other ones, like here. It's a good example. There's a couple other ones down here. We call these ears also, and they're really common in stemmed points in the interior Northwest, and I'm sure beyond. So if we start to pull together the stratigraphy of Area B, what we see is that these lower 3 pit features produced a whole bunch of radiocarbon dates that date on average probably close to 16,000 years. In fact, statistically, the radiocarbon dates from feature 108, 78, and 151 are the same. They overlap with each other. So they're very, very congruent, we might say. The upper part of this lower loess area is eroded. That's what the red dash line means. And so there's geological time that's lost. We don't have a complete record of all times being reflected with sediment. And so just on the other side of this erosional boundary, we see younger radiocarbon dates. So we jump pretty fast. So thousands of years have been lost. In fact, this red dash line also, conceptually, it exists in area A also. The top of the loess feature over there goes to about 13,000 years, but then it jumps to 11 to 12,000 years. So we're missing, unfortunately, the time period that's associated with Clovis. So the Clovis Paleoindian tradition is, around 12,900 to 13,100 or so. So it's a relatively short time period on that, around 13,000 years, but we don't have it at Cooper's Ferry. And I don't know what that means. Does it mean that people weren't making Clovis artifacts here, or maybe they were and it got eroded away? So it's very unfortunate that we couldn't measure it, but there's other parts of the canyon we might be able to find this evidence perhaps someday. And as we go up higher in the record, we get into other younger deposits that go progressively into the 11,000s and the 10,000s. And then we have the Sisson Formation, layer 16 here. And there's also some disturbance sometimes in this upper part that includes 20th century objects from the road construction, fill being pushed. Okay, so when we think about what the Nez Perce ancestral peoples were doing in the canyons of Western Idaho, we can look at things like the archaeological record, of course, but also importantly, we can look at what the Nez Perce people say, what the oral history of the tribe communicates, through stories and through song and things like this. But importantly, stories about places can often, be very, very informative. And so the Cooper's Ferry site, as I mentioned, is known as the location of a winter village called Nipéhe. And this concept of winter village is really about, essentially, as it suggests, it's a place you might live in the winter. So it's pretty cold there in the winter times. But if you're down in the bottom of the canyon, it's between 10 to 15 degrees warmer in the bottom of the canyon than it is the top of the canyon. And so we see in the historic and ethnographic period that Nez Perce peoples are living in these villages, for part of the year. A good chunk of the cold part of the year is down in the canyon, and then the rest of the time they're elsewhere in the landscape. So how can we measure this? What is the archaeological evidence for this? And it's not that I question the Nez Perce at all. I'm just seeking the thing that's sometimes really hard to do, and that is bring together traditional indigenous perspectives and archaeological evidence. So let's just see what we can do with that idea. So if I were to be thinking about the archaeological record of the site reflecting something like a winter village or just a village in general, I would have some expectations. One is we should see extremely intensive activity. That is, if people are spending months of the year living at one place, the density of artifacts should be very high. And also, we should not only find a lot of artifacts, we might also find a lot of features related to the everyday domestic life of people living there. And so we have recorded over 500,000 items out of the excavation units that I've shown you here, and we have over 100 features that we've recorded here as well. So we can check that part off the list. We also should expect to see some more complex sort of use of logistical strategies, things like equipment storage, maybe even, if we could see it, storage of food, but definitely at least thinking about things like equipment storage, because if this is an important place to live, we probably also begin to see a lot of the full range of diversity of different kinds of tools that might be present, and they're being sometimes stored for different times of the year when they're not being used. And so some of the pit features we found that have a lot of different, very functional tools in them. Yeah, some of these tools are broken, but a lot of them are not broken, but they're being put in the ground. Is that equipment storage? It could be something else, but it also could be about storage of tools. We should also expect to see the presence of animals that are being obtained during the winter months. And so this is an issue of seasonality that we can get to by looking at what animals are very more easily accessible at only certain times of the year, like the winter. And we talked about wolverine being one of those. And there's other things that we can begin to look at. But for me, wolverine's a pretty important one, that one is not going to be obtained probably in the summer months, and then brought back to the Cooper's Ferry site. You could get it somewhere else in Idaho, but it would be a long distance away. And also, I would expect to perhaps see houses, because if it's this cold, as I'm mentioning, and we're in the Pleistocene too. And as I showed you before that map, the continental ice sheets are not that far away. There's still a lot of glacial ice in the central part of Idaho and mountain glaciers. It was probably extremely cold and dry, and that's why we're getting all that windblown glacial dust. So I would expect to see houses. So what have we found, that relates to that? Well, let's first talk about our expectations of what houses might look like. So this is a photograph of an excavation at a site in the Snake River Canyon, lower Snake River Canyon, known as Weshpushnameé. And Weshpushnameé was excavated by Washington State University. And here you can see they're using a large block style excavation. In the distance, there's another one, but they're mapping in place a whole bunch of artifacts. In fact, the style of excavation here is that they would leave lots and lots of them in place and then take a photograph and make drawings and so on. What we do today is we just use laser transits and we map everything as we go, and we can digitally assemble maps using just a computer later on. So the distribution of items here in this case is being interpreted to represent the interior of a house. And you can kind of see on the edges, there are some parts that represent a bit of a berm or like a beveled edge to the inside of the house and the outside of the house. And here I've drawn the oval on it to kind of give you an idea of what we're looking at. And then from the profile perspective, here we can see that there's a shape that's cut down. It's cross-cutting through the geology, but it has this sort of descending depression shape. And this is the interior of the house and the exterior of the house. The interior is often filled with very mixed up sediment as the house is either collapsed on itself or it's, fills in through time after abandonment and so on. So there's the boundary. We might also expect to see architectural features. So Weshpushnameé is notable because there were some in-place post features that were present, and also charred timbers that laid in that deposit of collapsed roof and mixed up sediment, for example. Okay, so if we go back to the Cooper's Ferry site and look at our profile from 1997, just to orient ourselves, the orange arrow is showing you the position of the boundary between layer 6 and layer 5. So as the students were excavating through layer 6, I told them just to simply remove the brown sediment off of the tan sediment, because I wanted to see what the top of this surface looked like at the site. And as they did this, they were very mindful to try to tune themselves into what the stratigraphy was supposed to look like. So here, if this is your expectation, it's a layer cake. The brown is on top of the gray, for example, which is on top of the tan. You really start to look at the how it visually appears, also how it feels, how it sounds, and so on. You really got to get in the groove and really think about it. So if we go 2 meters to the south of that photograph I just showed you, we see that layer 6, this brown one, keeps on going, and it's over the gray layer 5. But as we go around the corner, it stops, meaning it seems to be sort of cutting down into layer 5. It's truncating it. And the top of layer 4 is being sort of affected here. We also see some vertical parts here that are unusual. These round parts are from rodents burrowing, and they will do this. They'll cut a tunnel down in here that can get infilled by sediment that's coming down from above or being pushed up from below. But these are from like Richardson's ground squirrel and other kinds of small burrowing rodents that don't want to make vertical shafts. So this is a vertical post hole, I think. And this is perhaps another post hole. I don't think that's a burrow, because rodents aren't making these sort of Mission Impossible ascending through this shaft like this, or like Santa Claus going up through a chimney. They're going to make, more sloping tunnels to come out of the ground. So this is our expected layering. As we move around the corner, it gets really quite messed up. So that was unusual. And this is my interpretation of maybe what's going on here. So the dash line shows the extents of what I think is perhaps depression from a foundation of a semi-subterranean house that was cut. There was also an oxidized area that we got radiocarbon dates on. I'll show you on this later from, I think it's a hearth. So I think there's a house feature perhaps here, and this isn't the best evidence. We'll get to that in a second. But if we turn, if we're looking at this surface right here, so we're going to turn sort of 180 degrees and look back on this surface. Here's another. It looks like a post, perhaps in the ground. We called this one the dirt carrot or the dirt icicle. Sometimes it was very unusual. And we also see there's some unusual patterns here on the surface. And this is the surface that's just underneath that brown. This is the gray surface underneath. And so there's some other features here. And this is the one I showed you earlier that ended up being the very ashy pit feature that had the very burned, base underneath it. So in 1997, we dug a 2x2 about right here. And this line extending, I think, is encasing and closing the interior of a house. And here we got down to the gray sediment, and here's a feature, here's a feature. But the students were, sort of dismayed because they're like, well, it's supposed to be turning gray, but it's still brown. I think it's still brown here because of this kind of thing I showed you. There's a depression cut in the surface. It's a little hard to show these complex 3D objects in sort of 2D panels like this, but here you can see the more messed up part where the house is likely touching the wall back there still. So maybe more convincing than just showing you that is the distribution of all the items in a 15 centimeter span of distance associated with that transition from the dark brown layer 6 and the light gray layer 5. So here is the interior of this thing that I think might be a house. Here are all the things that I think might be posts that are arranged where we found them. This is one on the outside here, but it may or may not be associated with this. It's hard to say. But some of these features on the outside have intense firecracked rock distributions. Inside the house, there are also some distributions of firecracked rock in here. And we also found a lot of fragments of weapons. So we have stemmed point pieces, blades of stem points, for example. This is a base of a stem point that's classically known as wind dust in the interior Northwest. It's a type of wind dust. It is associated with a hearth feature that returned to radiocarbon age between 11.2 to 11.3 thousand years ago. A lot of other pieces of material that is charcoal and also river mussel shell from the outside of this one feature, but inside the fill of the house were younger. They went from 9,800 to 10,200 about. So what we may be looking at is multiple uses of the house, or we could be looking at a situation where this is the true age of the house and this is just a piece of old wood that maybe got incorporated into this. We also found this unusual piece. This is a three-dimensional scan of it, but it's a piece of soapstone that was carved into, I think when it was complete, it probably had a mirror image. So it looked like kind of a flattened football with a vertical hole drilled through it. And it's absolutely smooth and polished, this hole that's drilled through it. So I think that what we're looking at here is the distribution of the occupation surface associated with a house feature. So this is consistent, I think, with the concept of a winter village house. And remember that even though we excavated a large block, I mean, there could be more of these at the site and we just didn't see them because we didn't actually sample the area where these were. And in the 1960s, B. Robert Butler's excavations here not only included the Cooper's Ferry site, but also he worked at a site about a quarter mile away up that little side canyon I told you about in the beginning at a place called the Double House site. And as the name suggests, there were two depressions at the site that they could see at the surface. They excavated them and they're late Holocene in age, but this is a reconstruction of one of the houses. The other one was circular. This one is an oval with rounded, or a rectangle with rounded ends. And as it's described here, it's a reconstruction of a house and it resembles the type built by the Nez Perce in historic times. So what I think is amazing about this is this looks extremely similar, I think, to the example that we are seeing at the about 10,000 years ago at the site. So this question of culture continuity and the perpetuation of cultural patterns, like making houses and surviving the winter and adapting well to your environment, is something that has very likely extremely deep roots in Nez Perce heritage in this part of the world. So I think that what we can say very clearly is that ancestors of Nez Perce peoples lived at the Nipéhe Ferry site repeatedly from at least 16,000 years ago, and the presence of features containing tools and reflecting intensive food processing. And I guess I didn't touch on this, but in addition to finding fire-cracked rock, we found thousands of pieces of animal bone about the size of your pinky fingernail or your thumbnail that are smashed up pieces of bone that very much look like they've probably been processed to extract bone grease. So the idea is that fat is actually something that's hard to come by in foraging societies most of the time. So often you have to kind of extend your food budget by processing it out of fat-bearing pieces of bone and things like this. I think that this is showing us not only intensive food processing, also seasonal animal remains and a large quantity of cultural material. This, to me, is extremely consistent with the concept of a winter village, especially the presence of something like what looks like a house feature. So the archaeological record may show us that village life at the site extends back into the end of the Ice Age. And even though the house feature itself only goes with, it only dates to about 10,000 years, the other associated patterns of creating pits, maybe storing items, even discarding of materials in these pits that are happening at the same time people are making houses are happening earlier as well. So it could be that there are houses to be found in other earlier deposits and we didn't find them. It's not a surprise to me that people would be making houses. I mean, if you want to try to live in the Salmon River Canyon this time of year without a shelter, I mean, you're taking a life in your hands. And I think that probably as long as people have been in the Americas, they have been making houses. It's just the archaeological resolution of these things is just not great. We're not necessarily digging the way that we're digging here. And that's really what it takes to actually nail the stuff down. If you're digging a bunch of small holes in the landscape, it's almost impossible to see a presence of a house most of the time. In fact, we missed it in 1997, I think. It only realized it until we dug a bigger hole later. So characteristic aspects of the Columbia River Plateau cultural pattern, I think, have roots that you can argue go into the late Pleistocene. There's not a huge shift in the lifeway from the very earliest time we can measure things to much, much later in time. And so, there isn't, even though they may be hunting megafauna, they're not changing necessarily their lifeway very strongly as far as we can tell. So I think that archaeological evidence of Nez Perce people may be present elsewhere at the site or in the Salmon River Canyon. So I don't expect that we have found the earliest evidence of people in the Americas. And in fact, I think that, you can't really ever really say that with confidence because archaeological samples are exceedingly small in the big picture. We really always wish we had more. But I think what's amazing about this is that Nez Perce oral history and the archaeological science are telling very similar stories here. So this is one of these situations where we have an opportunity to have both perspectives come together and sort of support each other. And that's pretty special. I haven't had a lot of opportunities for that, especially talking about something this early. Okay, so we'll kind of round this out by talking about, as I promised, how this fits into the biggest picture perhaps of all. And there's a concept that Dr. David Madsen and I and some others are going to be talking about soon that we refer to as the American Upper Paleolithic. And this represents a series of sites that we can see that are south of the glacial ice sheets. So Cooper's Ferry, Paisley Caves in Oregon's another one, the Galton Friedkin sites in Texas, Page Ladson. There's a couple of them I don't have on this. Cactus Hill, I think, is probably related to this, and also Meadowcroft Rock Shelter. Other sites in South America that are quite similar to this whole pattern include Huaca Prieta, and then in Peru, and then also Monteverde in Chile. And there's a series of these early sites shown here that date to this time period between about 14 to 18,000 years. And they have a lot of similarities in the production of stone tools. And some of these include the ways in which people make bifaces and unifacial tools and how they make cores, for example, as listed here. And bifacial tools are not only made by just the reduction of a large biface to make a smaller biface, but also bifacial tools are being made from flakes. And that's pretty common among, for example, the projectile points at Cooper's Ferry are made this way. But what's interesting is that what's consistent between these is a lack of fluted points in projectile point technology and the presence of stemmed points at multiple sites. I should also mention that the earliest archaeological sites with lithic assemblages that we know of in eastern Beringia come from the Nenana River Valley and include sites like Swan Point that's extremely early. You know, these sites are younger than a lot of these sites that are south of the ice. So that sets up a bit of a conceptual problem of, well, how did this happen? How did you actually get people down here south of the ice sheet when the ice-free corridor won't open until later and it's not viable likely as a route of migration? This is a separate, discussion, of course, and I'm sure that you all have thought about it, heard about, but myself and others have argued that likely people are entering from Northeast Asia along the coast and making a left-hand turn south of the ice, which gets you right into the Columbia River Basin. So here's some examples of what these technologies look like. So American Upper Paleolithic technology includes cores like this. We call this this is known in the region. I didn't coin this term, but in the Northwest, in British Columbia, into the US Pacific Northwest, Lavawa-like or Levawa-like, whatever your preference is, these cores and flakes are being made. So these are examples from Cooper's Ferry. And the idea is that you set up a core that has these kind of rotated flakes are removed from the margins, and then you strike off a large flake across the top. So here is the same core, but viewed in the side view. Essentially, it's as if you prepared this and you fluted the top and you took off a very large flake off the top. And why did people do this? Well, this technique is one that allows you to take flakes like this on the right. It allows you to take large linear flakes from circular or cylindrical packages. So if you have a nodule of rock that you want to take a long flat flake out of it that's thick enough to make into other tools, this is a technique you can use. On the right-hand side here, we see these are prismatic blades. So when we think of blades, like Clovis blades, for example, the Galt site in Texas is tremendous for this. There's a whole bunch of technologies that are actually similar in many ways to what we'll see later in the Clovis Paleoindian period, are found in layers deeper in the site than the Clovis layers. And these date into this time period, as I mentioned before, probably 14 to 18,000 years old. And here's a whole bunch of examples of these from the Galt site. There's a book actually coming out soon, I hear, from the people who worked at the Galt site that's going to provide a lot of new evidence about and in greater detail about the site itself. I can't wait for that book to come out. And if you guys want a really great presentation sometime, you should reach out to people at the Galt school, I think it's called, where they do this work. Someone maybe could give you a presentation on this. Here's also projectile points that date to this time period in the American Upper Paleolithic. These are older than Clovis. All of these that we show here in the photo. And here's the ones we've talked about from Cooper's Ferry, very familiar. At the Galt site, they also have these small stemmed points that show up. So here it is, centimeters for scale. The Friedkin site, which was excavated by Mike Waters at Texas A&M, right? It's adjacent to the Galt site, had stemmed points earlier than Clovis. Meadowcroft and Cactus Hill have other lanceolate that is, sort of stemmed but not fluted points. Large bifaces are also in the repertoire for people at Galt, for example. And also at Cooper's Ferry, we find really large flakes being produced from really large bifaces. We just haven't found the large bifaces yet. So all that hangs together, I think, in that way. And Cooper's Ferry relates to some of it in its own perspectives. But taken together with all these sites together, we can begin to start to visualize what the record of the Americas, at least in the time period we're talking about before Clovis, after the height of the last glacial period, what it's looking like I also, again, want to thank my research partners, the Nez Perce tribe. They've been tremendously supportive of the work that I do, and it's always an honor to be able to work with them about their heritage. The Bureau of Land Management has been a fantastic partner for me. I could not have done the work that I'm describing here, nor could myself and others from Oregon State University without the help of David Sisson at the Cottonwood office. So many thanks to you. Thanks a lot for inviting me again.
Well, thank you very much. Does anybody have any questions?
There's a couple questions in the chat. You'd like
Okay.
to go there first?
Okay, you guys want to read them to me, or do I?
There we go.
Should I get them?
Sure. One, were the canids brought here or were they already present?
So there's been some interesting work with the DNA of canids, for example, from the Americas. They're not as early as the things we've talked about, but and I believe also the one that was present in Vancouver Island, the genetics of them show that they are most closely related to canids in Northeast Asia. They're descendant from essentially wolves in Northeast Asia, not wolves in the Americas. And so the idea is that they traveled with people as they came into the Americas together. So in fact, the degree of genetic distance, the timing of the genetic mutation clock, as it's known, is similar among canids as it is among humans. So they also say that their movement into the Americas matches the timing and likely route also as humans. So people and dogs have been together since the Ice Age, at least. I mean, very early.
Yeah. Dr. Davis, does any of the bones, any animal bones that you found, you said a lot of them were crushed and stuff, but any of them show signs of butchering or cooking or fire or anything like that?
Yeah, a lot of them do. A lot of them are burned. A lot of them show, cut marks on them. Some of them are very fragmentary and small, so it can be a little difficult to be certain about that. But they're also their spatial distribution in pit features, along with other artifacts, gives us confidence that we're not looking at just a natural accumulation of bone. We're looking at cultural things. Unfortunately, most of them are so small, it's almost impossible to visually identify them to species. So we're, talking about the idea of using other techniques to perhaps, these are laboratory techniques that are not genetic techniques, but other kinds of techniques to look at the pattern of the proteins to figure out what animals they are. So that might happen in the future someday.
So you think they were eating Wolverine?
They could have eaten them. Wolverines also has a lot of other value. The fur, for example, is of a type that certain animals have fur that won't hold on to frost from like your breath. And so, for example, on the hood of a coat or a parka, if you ever wondered why it's trimmed with fur, well, that's to slow the wind down around your face to create a warm pocket around your face so it's not so intolerable. But also, too, the frost, with Wolverine fur, your expelled breath won't freeze to that. So you don't get a buildup of frost all around your face. So yeah, in the north, in Alaska and Canada, Wolverine fur is very prized for its warmth and hydrophobic qualities. So I don't know. I mean, you could eat it, I guess. I don't know. I've never eaten it, so I can't tell you if it's good to eat or not. But yeah.
Did you find any fish bones?
We find only a few, and they're really small. And so they are of the family that's, they're known as cyprinids, which is like in the stickleback family, and other fishes that are of types that are the predators of salmon, smolts, little salmon, baby salmon. So we don't find any salmonids early on. And that doesn't mean, of course, that people aren't using them. It's just that they're not leaving behind a record for us to measure at the site. There's also a lot of reasons why sometimes salmon bones don't show up. and why maybe even bones are being discarded the way they are. Or if there's dogs present, you can feed salmon carcasses, for example, to dogs. They'll eat the bones and things. So
I've got a question about a site, about an area that's about 60 miles north of you, the Lochshaw River. You're familiar with the Lolo Trail?
yeah, yes, ma'am.
I've heard that was an ancient trail for the Nez Perce to get into Montana for buffalo, but I've never heard of any time span as to how long ago they were using that.
Well, actually, I can say a little bit about that. That's great you brought that up. The Lochshaw River basin connects Idaho with Montana. So there's a highway now that you can drive on if you want to go to Missoula, for example. But there is a stone tool material there called vitrifier. And vitrifier is a type of volcanic rock that has similar qualities as obsidian. It's formed slightly differently, but we've actually found recently that the earliest layers at Cooper's Ferry have vitrifier from the Lochshaw River. And so people are going there, we think, and probably getting this rock and bringing it back. In visual appearance, it has like a dull green, glassy material. It almost looks like a plastic piece of great green plastic, like sort of olive green plastic. It's really unusual. So yeah, so at the end of the last ice age, people are getting vitrifier from the Lochshaw, and that would likely also be a route to get not only in the Missoula Basin, but if you were trying to get into the Great Plains. And that's the way, as you mentioned, it's the way the Nez Perce would go to. They would go bison hunting and bring back bison. So that was an important role that the Nez Perce play historically, is they are very entrepreneurial. So they would bring back materials from the plains and be able to trade them with the interior Northwest. And so to get that kind of material, often you had to go through the Nez Perce territory to do that. So they controlled that kind of trade route, essentially.
Yeah, we drove that road back 2004, the 200th anniversary of Lewis and Clark. The road is breathtaking. The scenery up there is amazing.
It is really amazing. It's really hard to drive because you're always kind of looking at the majestic scenery, but the road is really narrow and windy, as you remember, probably, and right near the river. So you got to not go over the edge into the river. But that's also the place where Lewis and Clark's expedition came into Idaho. They went through the Lolo Pass region, and it was such a rough travel. If you've read the journals, they talk about how they had many horses go down and people were injured and they couldn't hunt effectively and they were starving. So by the time they got into Idaho, they were in really rough shape, and they met the Nez Perce, and the Nez Perce gave them food and helped them continue their journey from that point. So in the retelling of the anniversary of the Lewis and Clark expedition, the Nez Perce have a different perspective, of course, about the whole thing, but it has to do with the Lochshaw River Valley.
I have a question.
Go ahead, Sandy.
Okay. I put it on the chat, but what kind of stone material are the stem points made from?
They are made mostly from, it's a chert. So think of it like an agate. Okay. It's an agate-like rock.
Yeah.
And it's found all over the canyon. It's not very rare. And the materials that we have found at the site can be sourced to places that are, I think the closest one is like, I don't know, 400 meters away or something, so they're really pretty close. And other ones are, other kinds of materials include fine grained volcanic materials like basalt and andesite. And those will come from the top of the canyon usually. But there's a feature that I didn't really show in detail here, but we found a pit in the lower, windblown glacial dust that included 5 large blocks of andesite that were, each of them were, I think, 75 to 100 pounds. And they just stored a whole bunch of these large blocks of really nice toolstone in a pit. So
interesting.
Yeah, that stuff's a little harder to work, but people still make really fantastic stuff. Obsidian represents about less than 1% of all the material. So people don't really go very far because they don't need to. There's a lot of riches of toolstone around them.
Interesting. Thank you.
You're welcome.
Here's a question. Stephen Neal had to go, but left me a question. And it relates to continuity of the people at the site.
Mm-hmm.
Populations tended to migrate and move around. Do you have any archaeological evidence showing that the same people lived at the site up through now?
Yeah. So that kind of argument, of course, is that people move around for sure. And in fact, even within the seasonal round or the annual round of the Nez Perce people, they wouldn't stay at a site like Cooper's Ferry all the time. And so they might spend part of the year outside the canyon, up on top of the canyon, up in the mountains, and then maybe come back to the same place. So sometimes people will ask me this, like, how do you know this is the ancestral record of the Nez Perce people? So we don't have anything that, is something like the genetic information that you might get from human remains. But the closest thing we can talk about is the ancient one, or the Kennewick man, as it's also known. The genetic information from that individual, who dates to, between 9 to 10,000 calendar years ago, shows that that person is ancestral to all the interior groups in the interior Northwest. That most of the interior Native American groups have ancestry that ties to that person. So genetically, I would imagine if that was something that could be measured, with permission with the tribe, that wouldn't be surprising that we would be able to measure it that way. Alternatively, you can look at the cultural patterns. And the cultural patterns, to me, that we see very early on, as I've described here, are something that's going to keep on going from 16,000 years ago to about 8,000 years ago. And so you have 8,000 years of cultural continuity. There's just not any tremendously different patterns that happen during this time. Sure, you can look at minute variations in the way people are making projectile points, but I don't really think that represents a true change in the people themselves. And so as a result, I think that the hypothesis that what we're looking at is the ancestral peoples that will later become known as the Nez Perce people, I think that is the prime hypothesis. That we can try to disprove it, I guess, but I've just never seen any evidence that would make me think that it's anything but that. That we're looking at the ancestral people, I think, of the Nez Perce. That people would maybe move around. So to flip this on its head, if you wanted to try to find something that might convince you that there's a big change, like one people came in and replaced another people, I would expect to see much more dramatic changes in the record. And we do see this in other parts of the world, where agricultural groups come in and replace non-agricultural groups, or people bearing entirely different technologies, microblades, or ceramics or something like that. That just doesn't happen in our area. Even so, it could be that those technological ideas come in, but yet the people stay the same. So for example, I point this out to students all the time, that technology is sometimes a measure of cultural continuity and similarity, and a lot of times not. That everybody in our chat group probably has a cell phone, and most of us might have an Apple product cell phone. Does that mean we're all related because we have the same artifact? I don't think so. So, there's only so far we could push it, with this. And some of this stuff might be very difficult to know, but that's my interpretation, is that we're looking at the ancestral peoples of the Nez Perce. And I think that's a good interpretation of the facts.
Good answer. Thank you.
There's another question in the group chat. Did you see any Younger Dryas evidence?
So the Younger Dryas also occurs, it overlaps pretty strongly with the Clovis period, as I mentioned. And unfortunately, that window of time is somewhat erased because of the erosion at the site. But we do have sort of the young end of it. And what we see is a shift back again to increased windblown glacial dust. So whereas previously it seemed like the glacial dust was slowing down a little bit, enough that you would get a soil developed, that soil then gets buried a little bit later by increased quantity of glacial dust being accumulated. So if that's a measure of increased cold and dry conditions, then yes, I suppose we do see evidence of the Younger Dryas. I mean, people are still at the site and they're still doing what they're doing. I don't know that it affected them all that much, but I know that's a popular kind of idea to try to look at small changes sometimes, or even large changes in climate environment. Sometimes I think it's amazing to see that even in the face of big changes to the world, people are extremely resilient and they just keep on keeping on, with similar approaches. Maybe they modify their approaches.
Well, there's another question here. I'll read it. Has there been any archaeological work on the islands west of Canada that might indicate movement from Beringia to the south along the North American coast?
Well, I know that the Canadian archaeologists are working on this. And here's some other names to throw out there for people you might think about inviting that could tell you better about this. And that's Duncan McLaren or Quentin Mackey or Daryl Fedge. These are archaeologists that work there. And they are seeking out early sites. And I think as it is right now, we're probably the earliest sites up there might be in the 13,000 year range, but that's not necessarily as early as we need to see. So if people truly did come down the coast, Pacific coast from Northeast Asia as maybe the initial or one of the early entries, the earliest archaeological evidence then should be in British Columbia and Alaska on the coast. And so I know that they are actively looking, and I'm always amazed at the things they come up with. That's some of my favorite, archaeology in the Americas comes from British Columbia, for example, on the coast. And so I'm always looking forward to new discoveries that they make. So I guess I would say right now, some of that record is going to be underwater, submerged by rising sea level. But because of the weird way in which the land has adjusted to the loading of glacial ice, depressing the ground, and also unloading as it melted away, there are parts of British Columbia near Haida Gwaii, which used to be called Queen Charlotte Island, but is Haida Gwaii. That island, there's a part of the island that has stayed in elevational position with rising sea level. So there are places you can go there, and at low tide, you can access the Pleistocene. And they have found Pleistocene age sites at low tide. And so it's an amazing place for that. Because it's these unusual sort of coming together of geological situations that makes it very advantageous, I think, for the Canadians to make big discoveries. So my money's on their work. That's where I think probably we're going to find a lot of that stuff.
Can you give me those three names once again? Duncan who?
McLaren, McLaren, Duncan McLaren.
And Quentin Mackey, and who is the third?
Daryl Fedge, Fedje. Daryl
Okay.
Fedge.
Do you know them personally?
I do, and I can help you get in contact with them. I think it'd be great. They would be great people to
I'll follow up for sure.
Yeah, let's do that. Sorry. And then also too, if you haven't heard from him, I work in Baja California with Dr. Matt Delorier, and he's at Cal State San Bernardino, and we work on Cedros Island, which is halfway down the Baja California Peninsula, and he would give you a great presentation. So I recommend you reach out to him too. So
I will. Thank you. Anybody else have any question? Well, tonight was an excellent presentation. Thank you so very much.
You're welcome.
And I want to I have your there it is. I have your certificate of appreciation that I'll be sending to you again, like the other one.
Yeah, I'll add it to my collection.
And Nick, I want to thank everybody for joining us tonight. And I just want to say that next month, in February 8th, we're going to have Dr. Ruben Mendoza back. When we had him a couple of years ago, he gave me a list of about 6 really great presentations he could give. And he talked about the turquoise trading and stuff last time. But this next month, the title of his talk is Night of the Night Sun, the Aztec Sunstone in Light of the New Fire Ceremony, AD 1507. That's the title of his talk. He was really a great speaker, and looking forward to having him back. And I thank, again, everybody tonight for coming and listening to Dr. Davis. And We've been honored. Thank you very much. Everybody have a very nice evening and good night.
Thank you.
Yeah, thanks, everybody.
Great talk. Thank you.
Yes,
Thank
good
you.
job. Appreciate it.
Yeah, you're welcome. Good night.
Good night.